Hi, this video is to help you understand how to do the experiment gravimetric analysis of a precipitation reaction. It's not meant as a substitute for the procedure. You should still look the procedure over when you actually do the experiment. It's just meant so if you watch the video, you'll understand a little better what the procedure is asking you to do. The first thing you have to do is to get your mortar and pestle, the calcium chloride, a weighing boat, and a scale. Get that stuff together and we'll meet back here. Now, the first thing you have to do is weigh out about 25 grams of the calcium chloride. So put a weighing boat on your digital scale, turn it on. It ought to read 0. If it doesn't read 0, press the tare button until it does, and then add the calcium chloride. You get somewhere around 25 grams. 24 to 26 grams is an okay range. All right, I think that's close enough. Okay. And in this experiment, we're not going to use that amount in the calculation in any way. So as long as it's in that range, you can proceed to the next step without writing anything down. And this takes quite a bit of work to grind up this much calcium chloride, and you have to do it gently so that you don't get it all over the place. But I'm going to start grinding. And I'm going to pause the video while I grind for a while. Okay. I've been grinding for a while and I'm making some progress, but I thought I should show you the good technique for not making a mess and getting it ground. The pellets will fly out and you do have to press them very hard. So a good technique to cover the mortar and pestle with your hand and just press directly in. All right, I'm just pressing directly in. I'm not trying to swirl as I grind. And at first it may look a little bit discouraging because as you grind it, the fine granules of power fall to the bottom. So the top always looks like it has unground spheres in it. But if you keep grinding, they will all get ground up. All right, I'm going to get back to it without the camera on. Okay, so I was grinding for about 5 minutes straight before I really felt like I got rid of most of the spheres, and my sample looks like a pretty uniform powder. And now I have to take that full mass of calcium chloride. I want to make a solution with it. And if you don't have a coffee cup around, like a thick-walled mug like this, you could use one of the Dixie cups from the kit. But it's going to heat up a little bit, so it would be a little nicer to have it in a cup like this. And it's harder to knock this over. So either one is okay, but I'm going to use a coffee mug. And I'm going to transfer all that solid that I ground up into the coffee mug. Then I'm going to measure out 25 mLs of tap water. Okay, that is just about 25 mLs. Okay. And I'm going to swirl this, and then I'll get my spoon and I'm going to stir it to try to get it all to dissolve. So I got the plastic spoon from my kit, and I'm going to spend several minutes doing my best to try to get this all to dissolve by stirring it. After a few minutes, when you think most or all of it has dissolved, we want to put this off on the side because we want it to cool down to very close to room temperature. If you have another bowl that you could sit it in to help cool it off, you could do that. But if you have to just lay it on the side and let it cool by itself, that's fine. So I have a bowl around the house, so I filled this up with just cold tap water. And after stirring this for a while, I'm going to put this in there to help cool it down to room temperature. Now, the next thing we have to do is prepare the magnesium sulfate stock solution. And we prepare that directly into one of these 100 milliliter mixing containers. So you can take the mixing container, a nice clean dry one, put it on the scale, turn it on if it's not on. It ought to read 0. If it doesn't, press the tare button. And then take out the magnesium sulfate heptahydrate. That's just Epsom salts you might take a bath with. And we want to add about 7 grams of the magnesium sulfate heptahydrate, and 6.9 to 7.1 would be an okay range. Okay, so let's just see if we can do that without too much trouble. Okay, all right, I went a little bit over. Let me pour a little bit back. 6.95, that's perfectly fine. That's in the range. Okay. And along with the mass of magnesium sulfate in here, we need to add 70 milliliters of water. So I'll get some tap water and see 70 ml marks around there, my finger on it. Okay, and that's just about 70 mLs of water. Cap on there, nice and tight, and give it a shaking up. Dissolve all the magnesium sulfate. Just a little bit more. Okay, this doesn't take as much work to dissolve as calcium chloride. Mine is all dissolved. Okay, you don't want to get confused, so we ought to label this solution. This is the magnesium sulfate stock. Now, the next thing we want to do is we want to filter this solution so that we have a saturated solution of the calcium chloride and that it has no extra solid in the bottom. So the way we do filtrations in this course is you use this, we call this a disposable funnel, and these coffee filters are what we use to do the filtration. We set that up on top of a coffee cup. Like that, and just pour the solution right into it. Okay. There probably will be some solid left behind. The amounts that you weighed out and combined were a little bit more than would form a saturated solution, so that we can be pretty sure the solution was saturated. So there should be a little bit of solid either in the filter or here. The solution that's formed is a saturated solution of calcium chloride is very viscous. It's going to take several minutes to filter. So we'll just take a little bit of a break for a minute and come back when it's gotten all the way through. While that solution is filtering, we want to get 10 of these 15 ml screw lid test tubes and label them with your permanent magic marker, numbers 1 through 10. There's number 1. So I'll call this one number 2. And I'm going to finish doing this with the camera off. Okay, I just finished labeling my 10 test tube, number 1 through 10. And each one of those test tubes, I'm going to add 6 mLs of the magnesium sulfate stock solution to, using a dropper. 6 mLs is just about 2 droppers full, but I'm going to measure by looking at the markings on the side of the tube. And use a dropper to carefully adjust. This is a very important amount you're measuring in this experiment. Okay, within a drop, you want it to be exactly at the 6 ml mark. Okay, so repeat that for all of the tubes, and we'll meet back here in a couple of minutes. I'll do it with the video camera off. Okay, so here I am with my 10th tube. Carefully adjusting to 6 mLs. Now I have 10 tubes here with 6 mLs of the magnesium sulfate stock solution. I'm going to put that off on the side. I don't need the magnesium sulfate stock solution right now. I won't need it unless I make a mistake and spill something. Okay. And the next thing we want to do is weigh out 10 filters and mark them up with their masses with a pencil. So take out your scale again. and count out 10 filters and get a pencil. Okay. Before you start doing this, you make sure your work area is dry. You can use your microfiber rag for that, because you don't want the filters to get wet as you're weighing, but before you weigh them. Okay. And if your hands are wet, make sure you dry them off thoroughly with a rag. Each one of these filters, we're going to mark up with one of the numbers for the trial. For instance, this is the first one for number 1. And we want to weigh it, and in order to weigh it so that it lays on the scale pan and doesn't flop over the edges, it's a good idea to fold it up about into quarters. Okay. 1.80. And we want to record that mass directly onto the filter. We're also going to copy it into the data table. If you want to get ahead, you could go and do that. But for the time being, it's adequate to have it on the filters. The filters' masses may be close to each other, but it's worth recording the actual mass. We're going to subtract it later on. So continue to do this. Produce 10 filters numbered 1 through 10 with their masses written right on them. Once you get those 10 filters weighed and labeled with their numbers and their masses, you can put those off on the side. I've got one of them here that I'm going to be using soon. And we'll turn our attention back to the saturated calcium chloride solution that we filtered. Right? When all the liquid has filtered through there, you can take this off. Mine looks like it hasn't quite filtered yet. Oh, it looks like I'm going to have to wait a little bit longer. Okay, I waited another 10 minutes, and it looks like almost all the solution has gone through. The amount of solution we prepared is a little more than we need, so if the last couple of drops hasn't gone through, that's all right. Now you can take this filter and funnel off, and this can be put in the garbage, or you can put it off on the side to throw it out later. And this solution we ought to label so we don't get confused. It looks a little bit like all the other coffee cups. This is the saturated CaCl2 stock. Okay. So the next is to turn our attention to running the reaction. The reaction is going to be run by combining the saturated calcium chloride that we prepared and filtered with each of these tubes that have the same volume, the 6 mils of magnesium sulfate. Every one of these tubes needs to get a different number of drops, and that number of drops is written here in the procedure and in this table. The first tube, tube number 1, it describes in detail all of the steps that I'm showing you, has to get 5 drops of the saturated calcium chloride. So get a clean dropper, okay, and count out 5 drops into test tube number 1. Okay. When you do that, you should see a reaction occur. You see the white solid that has just fallen to the bottom. That is the reaction that we're studying today, the precipitation of the calcium sulfate. Right? So as you see that precipitate, you can take one of the blue caps that come with these test tubes, okay, and cap it. Okay, and you can just gently mix it. If you want to shake it a little bit, you can shake it with the cap on. We just want to make sure everything in there is well mixed up, and then we can put it over here with our tubes that have had the reaction done to them. So we're going to continue to do that following this table. Test tube number 1 will get 10 and 20 and so on drops. The only difference is once we get up to the largest numbers of drops, 52 drops, it tells us that 52 drops is actually a volume of 2 milliliters. So when you get up to that point, you don't have to count all the way up to 52 milliliters. You could measure 2 milliliters. That would be starting with test tube number 7. Okay, here's my number 7. And what I'm going to do is I'm just going to look at the markings on the tube here. And I'm going to add, since it has 6 mLs of magnesium sulfate, I'm going to add 2 mLs of this by looking at the marking. So the total volume is 8 mLs. Okay, so here's my number 8 tube. It has 6 mLs of magnesium sulfate. I'm going to add up to the 8 ml mark. Very carefully to not overshoot. All right, so I'm right up to the 8 ml mark. If you look at the tube, you can see there. And then I'm going to do the same thing to cover it and shake it up. Okay, and you can do those larger volumes, continuing from tubes 7, 8, 9, 10, and so on, up to the last one, measuring milliliters by looking at the side of the tube's markings. Now, for each one of these tubes that you've run the reaction with, you're going to set up a filtration apparatus like I'm going to show you here, but I'm just going to demonstrate for one of them. So just like you did before, you'll take a clean Dixie cup, you'll put a funnel on top of there, then you'll take one of your pre-weighed filters, and the pre-weighed filter should correspond to the solution number. Like this is solution number 1, I'm going to use filter number 1. Okay. Here. Okay, and you can swirl the solution a little bit and then dump it in there for it to filter. After you dump it into filter, you want to wash the material out that didn't come, the solid that might not have washed out. Like he says, a lot of white solid on the bottom here. So do 1 full dropper full, squirt it in there. Okay. You can put the cap on. Put the cap on so you can shake it a little bit and dump that out. Look at the tube, and if there's any more residue in there, like that looks like a little bit of milky solution, then you can do that wash again. Okay, pour it right into the filter. It doesn't look to me like there's any residue left in there. The little bit of solution is stuck to the walls, looks clear. So that's enough washing for solution number 1. So you're going to do that for all of these tubes. You'll have 10 filtration apparatuses like this set up on your desk if you have the room, hopefully, to do them all at once. Now, once you can see that all the solution is drained through there and there's just a wet, muddy, white solid there, then you want to wash this filter. And this is a very important step in getting good results in this experiment. When we wash the filter, what we're doing is we're washing out the dissolved solids that are soluble. That would be either the magnesium chloride or the magnesium sulfate that's unreacted, and washing it out of the filter, because if we dry the filter with them in it, they're going to add to the weight we measure in the end. The only weight we want to measure in the end is the weight of the calcium sulfate that's been formed. So this is a very important step to do carefully. So you want to do a dropper full of water and use it to go up to the top of where the filter is wet, all the way around like that. And we're going to do 2 or even 3 washes, but with each wash, we want it to completely wash through and for the filter to look like it has a mud in the bottom with no puddle in it before we do the next wash. Okay, I've been waiting about 3 or 4 minutes for the liquid to completely wash through from the first wash. So now I'm going to do a second wash. Again, I go around the top of the filter, gently squirting and rotating like that. And I did 1 drop full. And again, I'm going to wait 3 or 4 minutes before I do my third wash. Okay, that was about another 3 or 4 minutes for that second wash to get through. And then I'm going to do a third wash. And again, the same thing, going around the upper edge of the filter, trying to get the liquid around the whole top rim. Now, this process of doing washes doesn't mean you have to do them each waiting 3 or 4 minutes. If you have 10 of them set up, you could set a timer or look at the clock, start off the first wash. By the time you get to the 10th one and you go back to the first one may have drained all the way through. It may have been 2 or 3, 4 minutes by that time. So with 10 of them, it may be a more efficient process than doing them one at a time. Now, after the third wash has completely drained through the filter, each one of these filters you want to take and put on the side in a place where they can dry. There's a lot of options in your house, probably of different ways that you could do it that would work well. In my house, I laid them near the radiator and in a position where they couldn't get knocked onto the floor, but where they're near the radiator on the windowsill. And that works very well to dry them. If you hang clothing in your house and you have a clothesline, you could pin them up on a clothesline to dry. If I were to pin them, I would pin them from the top edge here, because you want to make sure when they dry out that the solid here can't fall out of the filter. You don't want the filter to get turned upside down. Or if you really can't find any other place to lay them, you could just lay them out in your work area on the desktop surface. If you just lay them out to dry like that, I would suggest every day or two, if you have a chance when you think of it, turn them over so that the backside can get some air and can dry out. After a week, one way or another, most of the filters will be dry enough for the next part of the experiment. Okay, So it's been a week. My filters have been drying by the radiator. I can feel by touching them that this filter is very dry. So I just want to take it, being careful to not dump any of the material that's caught in the filter there. I want to fold it up like I did before. Okay. And turn on the scale. Okay, and just gently put this on there. Okay, record that mass in the data table. That mass is the mass that would go here. That's my trial number 1. So the mass of the filter containing the product is 2.47. The mass of the filter I wrote right on there was 1.80. Okay, and the only calculation you really have to do in this lab is to calculate the difference between those two. 2.47 minus 1.80. I think I could do that in my head. I think that's 0.67 grams. So repeat that for all of your filters and calculate these masses. And the graph that you have to prepare is a graph with the number of drops of calcium chloride on the x-axis and the mass of the product formed on the y. Don't assume that your data should be like mine. I may have faked it up a little bit so as to not give away a secret.